Hi guys, welcome to another Golang programming tutorial on esoteric tech. In this video, I'm going to be covering how to use functions as values. If you're like I was when I first started programming, you might find the concept of accepting functions as parameters and returning functions from other functions to be somewhat confusing. I know I did, even though I'm not exactly sure why I thought it was confusing. But once you get it, you're kind of like, why did I even think that was so hard? And hopefully you guys get to that point much faster than I did. This is the second part or the continuation of last week's intro to Golang functions, where I covered how to define them, how to use them, and how to pass and return multiple values from a single function. And if functions are new to you and you haven't seen that video, I encourage you to watch that because those topics are a prerequisite to this one, which is slightly more advanced. So I'll talk about functions, how to use them as a type. I'll then go into anonymous functions and closures, and then I'll end with, as I said, how to pass and return functions from other functions. This entire tutorial is going to be coding examples that illustrate these concepts, so I'll make sure that I explain everything along the way so you guys can follow me. And as always, if you find this tutorial to be helpful or informative, please do subscribe. That feedback and support is very, very much appreciated. Let's go ahead and get started. In the last video, I gave the definition of a function signature, and that refers to the parameters, like you see here, and the return type of the function. So if any function has the same parameters and return type as another, they're said to have the same function signature. And understanding that is important when it comes to using functions as values. And that's really what it means when you hear the term first-class functions. It means that they can be treated just like any other variable. And I'm going to illustrate this by creating a very basic calculator. This is going to be a calculator that actually stores the logic for how to execute certain mathematical functions and operations like a real calculator. And I'll add functions like, how to add, subtract, multiply, and divide to store in that calculator. And so to start off, the first thing I'll do is actually define these functions which perform the operations. What I've done here is write out 4 separate functions: add, subtract, multiply, and divide, which each take in an integer, actually take in 2 integers, perform the appropriate operation, and then return the value. By the way, you may have noticed that I have included all of the logic for each function on one line. And this is completely legal in Go. I could have just as easily placed the logic on multiple lines, which is what you've seen me do in the past, but this just saves some space. So I'll go back to that. So I've got the functions of my calculator written out. And this particular calculator is going to be one that takes in a set of strings as the expression and then basically performs the operations based off of the values of those strings. And so what I'm going to do is create a map to map out certain operators to certain functions within the calculator. And I'll do that here in the main function here. And so this is going to be an operation map, so I'll call it op map. And this is going to hold a map of type string. And it is going to map that out to a function with a certain type of function signature. And so this signature is going to be one that takes in 2 integers and returns an integer. And you may have already noticed that the functions that I defined below have that exact signature. They take in 2 integers, return 1 integer. So that means that they can exist and be stored as values in this map. And so what I'm going to do is map out each operator to the corresponding function. And again, the reason I'm able to store these functions within this map is because they meet that signature. And I'm taking advantage of the fact that we can treat these as first-class functions. Now I've got the logic for my calculator. What I want to do is actually create some expressions to pass into this calculator. So let's go ahead and create a expressions variable. And what I'm going to do, this is actually going to be a slice of strings. Okay. So if you consider a slice of strings to be basically just a list of different strings, all separated by commas. Well, a slice of strings is a list of those types of strings, right? So it's a list of strings, which hopefully isn't too confusing. Okay, so I've written out all of the expressions that I want this calculator to calculate. So as I said, this is a slice of string. So one slice contains all of the necessary logic to perform one operation. And I've also refactored the actual op map out into a package level variable instead of one that is defined within the main function. And I did that just to make it a little bit more readable. And so now that I've got the expressions that I want to actually calculate, I'm going to go ahead and implement the logic for the calculator. So what we're going to do is just loop through this list of expressions and calculate or perform the calculations of each one at a time. So first I'm going to start out with my for loop. And as I said, I want to loop through that expression slice. And first thing I want to do is check and make sure that the actual length of the expression is the correct length, because it's got to have two operands and it's got to have an actual operator. So the expression length should actually be equal to 3, right? And if that's not the case, then we're going to go ahead and print out an error letting us know that it's an invalid expression. Invalid expression, if I can spell here. Looks like I cannot. Invalid expression. And then we're just going to pass in that expression there, right? And so, and if that happens, then we'll just go ahead and continue on to the next one. So that continue is a keyword there. Once I make sure that the expression is the right length, I want to make sure that we can actually perform the operation. So we want to check our map and see if that operator is actually in our map, right? And we can check if that value is in the map by using this OK return value. So whenever you actually get the values of a map, if you return two values, the second value that you return will actually be a Boolean indicating whether or not that value or that key actually exists in the map. So for example, if I put in op here, what I'm doing is first getting the indice of the expression. So this first indice, so number 1 is here, and that's going to return, you know, these, and then I'm checking to see, okay, does this key exist in the map? If it does, it would turn true, and then it would turn the value and store it in this opfunc variable. And then I want to add some type of logic here that actually prints out an error statement if that key does not exist in the map. So we'll do unsupported operation. And if that is the case, then we'll go ahead and continue to the next operation in the list. If the expression of the operation and the operator are both valid, then we can go ahead and convert the actual operands into integer values to actually perform the calculation. And so I'll go ahead and implement that logic. And the logic for this actually will be pulled in from the string conversion package, which is a built-in Golang package. And the function to convert a string to an integer is this a to I function. And so you pass in the actual string itself. Oops, and that's a 0. So I'm going to pass in the string itself. And if it cannot be converted into an actual integer, then it will return an error as one of the return types. And we'll go ahead and print that error out if that is the case. So that is the first operand, and we'll do the same thing for the second one. And if everything checks out, if It's the right length. It's got the operator. Both operands can be converted into integers. Then we go ahead and perform the calculation. And how do we know what calculation to perform? Well, we have that as a function in our op map. And so we're just calling that same function that we return by passing in that key value up here. Or I shouldn't say calling. We shouldn't say, passing it in. I should say calling that function. And it's going to be P1, P2, which is going to give us our result. And we're going to go ahead and print that result out. All right, so hopefully all of that makes sense here. There are a few things I need to do here. First of all, I need to add in this range keyword that I forgot. Also, I need to import the string conversion package. So let me go ahead and do that. So let's go ahead and run this and see what happens. Alrighty, so we can see here that it went through and performed the first few operations, and then it got to the last two, which actually it was not able to convert these over to integers, and this one didn't have enough strings in it to perform the operation, so we got errors back for those last two. So this was just a really basic example showing how you can use functions as values, storing them, inside of a map as long as the function meets that function signature requirement. One thing I also could have done is actually defined a function type or a new type that has that function signature. So let's say I wanted to say opfunc type and then define that actual signature here. So function that takes in two integers, return an integer. And so now I'm saying that this new type and any variable that meets this function signature can be stored as this type, right? And so instead of having this here, I can now say opfunc type. And this is the same thing. So you may be wondering, well, why would you ever want to do it like this? It's just best practice that if you're ever going to refer to something multiple times, oftentimes it's good to give it a name. So this opfunc type, I've got multiple signatures that refer to this. And so I can say these all meet the opfunc type signature. Another thing that Golang allows you to do is define what's called anonymous functions, which are pretty much exactly what they sound like. They're functions that don't have a name. And I'll give you an example of one. This here is a really basic example of an anonymous function. Here, I just define the function using the func keyword. You can see that I actually define it inside of the main function. So I don't even give it a name. I just say func. I notate or include its parameters here, which is of type integer. This one doesn't have a return type. And then I just define or declare the function of the body. And so this literally just takes in an integer and just prints out a string with that value inside of it. And this here is what you use if you need to call the function or if you want to call the function immediately after you define it. So I'm doing this within a loop and I'm defining this function and then passing in the value I. So this is all looking good here. So we're going to iterate through this list 5 times. So let's go ahead and run this. All right, and we can see that we successfully printed through each one of those iterations there. Another use case for anonymous functions is to create closures. Now, closures is kind of a complicated and sometimes difficult to understand topic, but a closure is basically a function that references variables from outside of its own body. And this function can basically be used to access and assign values to these referenced variables. And so it's kind of like the function is bound to those variables, and that probably is very confusing. So let me just write out some examples here and then I'll go through them. Okay, so here's a really basic example of a closure, and while I say basic, the truth is that understanding closures can be far from basic. They can be sometimes difficult to understand. And so I'm going to take this kind of very slowly and step by step. So I have created this new function called integer sequence, or intsec. And right off the bat, we can see that this function returns another function that returns an integer. And so let me say that again. This function intsec returns a function that can be called. And when it's called, that function returns an integer. And so right off of that, you know that within the body of this statement, of this intsec function, you're going to have a return function that returns this, that returns this type, this signature here, a function that returns an integer. And when we get into writing the logic of intsec, the first thing we do is we initialize a new variable I and set that equal to 0. So we've got this variable defined within intsec, and then we get into the return statement. And as I said, we already know we're returning a function that returns an integer, so that's exactly what you see here. But this is where we actually define the body of this function that's being returned. And this is what is unique about closures. Within this function, all we're doing is incrementing the value of I. But this is unique because we're able to access the value of I even though it's defined and declared outside of that function body. And so this returned function is all it's doing is incrementing this value by 1 and then returning that value. So that means that this variable only gets initialized to 0 when this function is called, when intsec is called. Whenever we call the function that is returned from intsec, it's just incrementing the value. And that's what you see up here. So intsec is called once, and we create this next int variable, which is really a function that can be called because that's what it returned, a function that now has this logic in it. But it's unique because it's bound to this variable that was declared within the scope of intsec. So it's kind of like a function with a stored variable, a bound variable. So each time you call next int, which is the function that was returned from intsec, it's just incrementing that variable. And so if I run this here, we can see that the first time we ran next int, it printed out 1, then it printed out 2, then it printed out 3. And then when we ran this intsec function again, it initialized this variable to 0 again. And then we ran this new int, which is the variable or the function that got returned from this second call to intsec. And then you can see the variable is 1 again. So each one of these variables are functions that store their own bound parameters. And that's the kind of unique feature of closures. If you guys are back-end developers or hoping to get into back-end development using Go, closures are something you're going to have to be familiar with because you will see them often when you start to get into writing different API handlers on the back end. This discussion on closures has provided us with a nice example of how to return functions from other functions, which is one thing I said I would discuss. But I also said I would discuss how to pass functions as parameters into other functions. So I'll give an example of that before I wrap up. So to illustrate a situation where you would pass in a function as a parameter, I have decided to use a very popular use case, which is the slice function that exists within the sort package, which is a built-in Go package. And so this slice function can be used to sort a slice of, basically a slice of values according to different attributes. You can sort it by integers, you can sort it by strings alphabetically, but you can do that by passing in a couple of parameters. One, you need to pass in the actual slice itself. And then second thing you need to pass in, as you can see here, is a function that takes in two integers and returns a Boolean. And this function is kind of like the logic that the slice function is going to use to perform the sorting. And so there's a lot of like back-end or magic logic behind this. And I say magic because that's kind of the term for functions that kind of have a hidden implementation. And for the most part, Go is pretty good at like staying away from that type of stuff. But if you want to learn more about the slice function, you can look at the Go documentation. But for the most part, all you need to know is that it takes in a slice and it needs to take in the function that, as I said, describes the logic for how it is going to perform the sorting. So I'm going to pass in people, which is this anonymous struct that I've defined up top here. And if you're not sure about anonymous structs, I encourage you to watch my video on structs, and that will bring you up to speed on that. And then the second part that I need to pass in is a function that, as we said, takes in two values, two integers in this case, and then it basically determines how it's going to implement that logic by whatever we put here in the body of the function. So we're going to put return. We're going to sort these structs here. We're going to sort them by age. And so we're going to return people I dot age less than people J dot age. And again, what it does with this logic is kind of hidden, but what I'm illustrating here is the fact that slice is a function that takes in another function as a parameter. It actually calls this function internally to figure out how to sort the slice that gets passed in. And so it's sorting it according to this age, which I've identified here. And then what I'm going to do is actually print out this slice, and I'll put out by age, and there we go. So if I run this here, it should sort these accordingly. And there we have it. We can see that it has sorted these by age from lowest to, or I'm sorry, from youngest to oldest here. And we can also do the same thing and by sorting these in alphabetical order. So if I wanted to, I could just change this to name there, and then let me change this string by name and then run this. And there we have it's in alphabetical order now. So if you guys, as I said, if you want to learn more about this sort function, I encourage you to read the documentation. But I think this pretty much wraps it up. So in this video, we've talked about how to define a function as a type. We've talked about anonymous functions, closures, and I've showed you examples on how to pass in and return a function from another function in Go. And so if you guys have any questions, please leave them in the comments. As I mentioned before, please subscribe and like, and I will catch you guys in the next tutorial here on Esoteric Tech. Thanks for watching.